So we have two more sections in this unit. Today's unit is going to be graphing linear inequalities, which mean we have two variables. And then our last section of the unit will be graphing systems of linear inequalities. So today when we graph linear inequalities, we'll also look at some absolute value inequalities. The first thing we're going to look at is this graph in the middle. It says the graph of the linear equation y equals x plus 3 separates the coordinate plane into three sets of points. One set is the set of points that are actually on the line from the linear equation. The next set of points are all the points above the line. And the last set of points comes from all the points below the line. The region above and below the line are called open half planes, and the line is the boundary of each half plane. If you start at any point on the line, say point P, which is 2, 5, and move upward from P, you'll notice the y coordinate increases. The values of y will increase. If you move downward from point P, the y coordinate decreases. Thus, the upper open half plane is the graph y is greater than x plus 3, and the lower open half plane is the graph of the inequality y is less than x plus 3. The graphs of blank completely cover the coordinate plane. Well, what covers it? That's highlighted. Y is greater than x plus 3. The equation y equals x plus 3. And then y is less than x plus 3. All of those together cover the coordinate plane. When the boundary line is included with an open half plane, it is called a closed half plane. The graphs of the inequalities are shown by shading. If the boundary line is part of the graph, it is drawn as a solid line. However, if the boundary line is not part of the graph, it is shown as a dashed line. Let's look at example A, B, C, and D. In A, we have y is greater than x plus 3. That is a dotted line, meaning that the points on that line are not included in the solution. Only everything shaded above is. And we know that it's going to be dotted because it's a greater than symbol that does not have the equal to with it. In B, you'll notice y is greater than or equal to x plus 3 is a solid line. That means those points are included along with all the shading above. All of those points are solutions to that inequality. In C, y is less than x plus 3 is a dotted line, meaning the points on the line are not included, but everything below it is. In D, we have y is less than or equal to x plus 3. It's a solid line because of the equal sign, meaning the points on the line are included, and so is everything that is shaded below. Okay, what are the steps for graphing a linear inequality? They're going to be similar to graphing a linear equation. We're going to solve in terms of y, so y is alone on one side. Then we're going to be looking at how to graph the line by looking at the inequality. If it's greater than or equal to or less than or equal to, we'll make a solid line. If it's greater or less than, we'll use a dashed line. Then we'll have to shade. If y is less than or equal to, we'll shade below, but if it's greater than or equal to, we'll shade above. We have four linear inequalities that we're going to practice. If you scroll down to the next page, we have 4 coordinate planes, and we will go ahead and graph each of those on one of the coordinate planes. Number 1 is x is greater than 4. X is greater than 4. If we think about that as an equation and say x equals 4, that means we're going to go over 1, 2, 3, 4 on the x-axis. And what kind of line does that make? It makes a vertical line through x equals 4, and it's going to be dashed. We know that because there's no equal to with that inequality. So we make a dashed line, meaning that the points on this line are not included with the solution. We go back to the inequality, x is greater than 4. Well, where are the values greater? Are they greater to the right of the dashed line we made, or to the left? Of course, to the right. As we go right, the values of x get larger. So we will shade everything that is to the right of x. Our second inequality is y is less than or equal to 3x plus 1. In this one, it's in slope-intercept form, so our slope is 3. Our intercept is 1. To graph this, we graph it just like a linear equation. From the origin, we will go up 1 on the y-axis. From there, we will go our slope, which is up 1, 2, 3, and to the right 1. Down 3, and to the left 1. This is going to be a solid line because it has a less than or equal to. I go ahead, well, that's a terrible graph, and graph my line. And then I do my shading. Y is less than or equal to. So if I think of a point that's on my line, and if I'm going down, my Y values on that line are also getting smaller. So I will be shading everything to that right of that line and below. So the solutions are everything on the line because it's a solid line plus everything I shaded. Okay, let's go to number 3. Number 3 is 4x plus 5y is less than or equal to 10. I'm going to get y by itself by subtracting 4x. I end up with 5y is less than or equal to negative 4x plus 10. To get y by itself, I'll divide by 5. And I get y is less than or equal to negative 4/5 x plus 2. My slope is negative 4/5. My intercept is 2. Again, I graph this just like a linear equation. From the origin, I go up 2. I then do my slope 1, 2, 3, 4 down, 1, 2, 3, 4, 5 right. I can go up 1, 2, 3, 4 and left 1, 2, 3, 4, 5. This is also a solid line because it's less than or equal to. And when I graph, where are my y values getting smaller? And they're getting smaller below that line. So again, every solution on the line plus everything below it makes it true. Okay. Let's go to number 4. Number 4. X plus 2y is greater than or equal to 4. To put this in slope-intercept form, I'm going to subtract x. When I do, I get 2y is greater than or equal to negative x plus 4. To get y by itself, I divide by 2. And I get y is greater than or equal to negative 1/2 x plus 2. None of these divided or multiplied by a negative, but remember, if you do, you have to switch that inequality symbol. So now we have a slope of negative 1/2 and an intercept of 2. Just like we graph linear equations, from the origin, I'm going up 2. From my y-intercept, I'm going down 1, right 2. I can go up 1, left 2. And this is also a solid line, and it's asking for the values that are greater than So if I pick a point, I know as I go up, my values of y are getting greater, and because it's a solid line, all the points on the line are solutions. Okay, so hopefully that seems pretty familiar to you, other than possibly the shading because it's an inequality. On the next page, we're doing it in reverse. They're giving us the graph of the linear inequality, and we are going to actually write the inequality. So let's look at the steps. It says write an inequality for the graph at the right. Find the slope and the y-intercept, write the equation. All right, so we know the y-intercept, that's b, and we know it's hitting the y-axis right here at 2. You can find the slope a few ways. You can take those two ordered pairs and do y2 minus y1 over x2 minus x1, or you can just do rise over run. So in this case, I'm going to rise 1, 2, so that's positive, and then I'm going to run 1, 2, 3, 4. And when I run 4, that's going in my denominator, and I can simplify that. So m equals 1/2. So my slope is 1/2, my intercept is b. I have a dashed line. Okay, that means that the solutions on the line are not included. Where is it shaded? It's shaded above. So that means that since it's dashed and it's shaded above, it's going to be a greater than symbol. So I can write this as y is greater than 1/2 x plus 2, and I'm done. Okay, let's try these other two examples. All right, where's it hitting the y-axis? It looks like it's hitting the y-axis at -4. From here, I can rise and run. So in this one, I'm going down 1, 2, so that is going to be -2, but I'm going 1, 2, 3, 4, 5. All right, so I'm going over 5. So my slope is -2 over 5, and that makes sense because my line is falling from left to right, so it's a negative slope. It's a dashed line, and it's shaded above, so that tells me it's going to be greater than. So I get y is greater than -2/5 x minus 4. All right, let's look at this next one. My y-intercept is b equals 3. My slope, I'm going down 1, 2, 3. I'm going right 1, 2. So my slope is -3 over 2. And then from there, I have a solid line. And when I graph, I need to decide if it's the values are getting bigger or smaller on this side. Okay, so when I go up, the values will be getting larger. Okay, so we have solid line greater than or equal to. Y is greater than or equal to, let's see, we went down 3 and we got to redo that slope. That's not correct. We went down, I wasn't hitting a point. I was just going to that middle one. How about if we go down 2 and we go right 1, and that's our slope. That looks a lot better. All right, so y is greater than or equal to -2x plus 3. -2x plus 3. And you'll see that anywhere on this, any point you go up, these are all, y values are increasing, so that tells you that it's greater than. Okay, I hope that helps. Okay, we're going to look at two equations where we're graphing absolute value inequalities. Or not two equations, but two inequalities. Graphing absolute value inequalities is similar to graphing linear inequalities. The graph of the related absolute value equation is the boundary. This boundary is graphed as a solid line if the inequality is less than or equal to or greater than or equal, and is dashed if the inequality is less than or greater than. Choose a test point not on the boundary to determine which region to shade. Okay, so let's look at these. So y is greater than x. So we look at this and we know that we have two unknowns. So let's make a chart. If I make a chart and I say, let's let x equal -2. Well, the absolute value of -2 is 2. Let's let x equal -1. That means y is 1. 0 is 0. And if you'll notice, if I let it equal 1, y is 1. 2, y is 2. So when I go to graph this, it's going to look like a V shape. I have 0, 0. I have -1, 1. I have -2, 2. I have 1, 1. And I have 2, 2. Okay? Now, this is going to be dotted because it is just a greater than symbol. So you're going to dot a V shape on here. Then we have to pick a point. When we pick a point, it says to either pick something above or below. I'm going to pick x0 and I'm going to pick y as 1, and I'm going to plug that in to see if it's true. So the absolute value of 0 is 0. Is 1 greater than 0? That is true. So this is the point I picked to test. Since that is true, that is where I shade. So my shading will be everything I don't know, above the V or inside the V, however you want to say that. We have to stop here, and I'm going to have to do that very last one for you in a separate video. I'm sorry.